Today's lesson is about correlation between two variables and the best fit regression line. The correlation between two variables, we have the following situations. If the trend is upward, we see it has a positive correlation. If the trend is downward, we see it has a negative correlation. If all the data are randomly scattered points, we see these two variables have no correlation. Linearity, these points are roughly linear. Let's check the second graph. These points do not follow a linear trend. When we describe the strength of correlation, we normally use strong, moderate, or weak. Here are some diagrams showing that strong positive correlation, moderate positive correlation, weak positive correlation. This is a strong negative correlation, moderate negative correlation, weak negative correlation. Outliers. Any outliers or isolated points do not follow the trend formed by the main body of data, like this one. This point is not an outlier because it follows the trend. There is a formula to decide whether a data is an outlier or not. Lower limit equals the first quartile minus 1.5 interquartile range. Upper limit equals upper quartile plus 1.5 interquartile range. Normally we use Pearson's correlation coefficient R to show the correlation. If R equals 1, that means two variables have a perfect positive correlation. When R equals -1, they have a perfect negative correlation. The stronger positive correlation, the closer to this 1. The stronger negative correlation, the closer to -1. There is a formula for this correlation coefficient. You can get Pearson's correlation coefficient R by graphing calculator, like this. We can also use covariance, standard deviation of X, standard deviation of Y to express this correlation coefficient. Normally, in statistics, for sample, we use X bar stand for the mean. We use S sub n square stand for variance. S sub n stand for the standard deviation. But for population, normally we use mu to stand for the mean. Use sigma square stand for the variance. Sigma stand for standard deviation. The coefficient of determination are square. If there is a causal relationship, then R square indicates the degree to which change in the independent variable explains change in the dependent variable. For example, there is a strong correlation between preparation time and the grade. It's found that R squared equals 0.81. An interpretation of these R square values is 81% of variation in grade can be explained by the variation in preparation time. In other words, we assume that the other 19% of the variation in grade can be explained by other factors. Now let's talk about best fit regression line. First of all, we can use graphing calculator to find the best fit regression line like this. You will write down y equals 4.68x plus 61.8. Also, we can use the following formula to express the best fit regression line. S sub xy means covariance. Standard deviation of x, we use S sub x. Standard deviation of y, we use S sub y for this formula. How to draw a line of best fit? If there is a strong linear correlation between two variables, we can draw a line of best fit to illustrate their relationship. First of all, you need to calculate the mean, then get the mean point. Make sure you draw a line through the mean point, which fits the trend of the data, so that about the same number of data points are above the line as below it. When you use best fit regression line to predict an event, we have interpolation and extrapolation. When you predict a value from x value, the accuracy of interpolation depends on how linear the original data was. From this diagram, interpolation means when you predict a value from x, this x is between minimum and maximum data. But the accuracy of an extrapolation depends not only on how linear the original data was, but also on the assumption that linear trend will continue past the poles. Extrapolation means when you predict value from x, which is beyond the maximum and also the minimum data. Then you need to consider whether it is reliable. You need to make sure whether the linear trend will continue past the poles. For guided practice 1, match each scatter diagram with the correct value of R. We know B, it will be R equals 1. E, that's R equals -1. For A, that's a positive correlation, so R equals 0.6. For C, R equals -0.7. This is R equals 0, no correlation. Now let's go to practice 2. A teacher asked the 5 students how much time they spent preparing a test. The results are shown in the table, along with the grade awarded to the students. Draw a scatter diagram to illustrate the data. Look at the preparation time, that's X, from 1 to 7. So we can do from 0, 1, 2, 3, 4, 5, 6, 7. For grade, it's from 65 to 95. Therefore, I can cross this. I can get started from 65, 70, 75, 80, 85, 90, 95. Then we plot the point. 595 is here. 4.580 it's here. 790 here. 165 is here. 375 is here. If we want to draw a best fit regression line, make sure you will get mean point, which is 4.1 and 81. So we plot over here 4.1 and 81. Then when you draw the line, make sure pass through this mean point. Now let's go to B. Evaluate R using the formula. We will fill out this table. We have 5, 4.5, 713, 95, 80, 90, 65, and 75. Mean for X, that is 4.1. Mean for Y, that's 81. After we fill out this table, we can use this formula to work out this R. So R equals 95.6, then you do square root 20.2 times 583. The answer will be 0.881. Therefore, it's a high positive correlation between preparation time and the grade. Let's go to C. Use graphing calculator to find the R. First of all, remember, put the diagnostic on. Then go to Stat Calculate, go to 4, Linear Regression AX plus B. L1, that's for X, L2, that's for Y. Store regression equation in Y1. Then put enter, you will get this. This is R, 0.881. We already described the stress, that's a high positive correlation. For E, use the following formula to find the equation of a best fit regression line. Remember, for the graphing calculator, this is sigma Y stands for the standard deviation for Y. Sigma X stands for the standard deviation for X. Therefore, we will get Y minus 81 equals 0.881 times standard deviation for Y, that is 10.7. Standard deviation for X, that's 2.01. Then we do X minus X bar, that is 4.1. After you organize, you will get the Y equals 4.69X plus 61.8. For F, use the graphing calculator to find the equation of a best fit regression line. It's given from here. You will see Y equals 4.68X plus 61.8. You could see these two regression line almost the same. Now let's go to J. Use the regression equation to estimate the grade if one student prepare a speech for 2.3 hours. You are given the regression equation by graphing calculator. So we get Y equals 4.68 times 2.3 plus 61.8. You will get 72.6. For 8, use the regression equation to estimate how much time one student prepare a speech if his grade is 73. So we set up 73 equals 4.68x plus 61.8. Subtract 61.8, then you divide it by 4.68. You will get the x equals 73 minus 61.8 over 4.68. You will get the x equals 2.39 hours.